with me into the ruins of a bombed-out factory in Warsaw, 1943, where the air tastes of brick dust and burned metal, and where every clang of a hammer carries the weight of defiance. Nazi forces ruled the streets, controlled every rifle, every bullet, every official weapon in the city, but deep in the shadows, Polish resistance fighters were doing the impossible. They were turning shattered radiators into multi-barrel guns, bending bicycle parts into grenades, transforming water pipes into makeshift mortar, scrap metal, household tools, broken furniture, anything that could be shaped, sharpened, or repurposed became part of a secret war fought with creativity as much as courage. These were not crude toys thrown together in desperation. These were engineered solutions, born from necessity, crafted by people who understood that survival demanded innovation when the usual rules no longer applied. And Warsaw wasn't alone. From the caves of the Pacific Islands to the workshops hidden behind enemy lines in Europe, the same scenes were unfolding. Regular soldiers cut off from supply lines, partisans, living in forests without industrial support, resistance groups operating under the constant threat of discovery. All of them turned landscapes of destruction into laboratories of improvisation. World War II, more than any conflict before or since, became the greatest proving ground for improvised weaponry in human history. From British garages hiding tiny Sten gun factories to French resistance fighters receiving Liberator pistols dropped from the sky, the war rewrote the idea of what could be built and who could build it. These inventions were not just acts of survival. They were acts of engineering brilliance, performed under conditions no designer or machinist would ever choose. They didn't just win battles. They reshaped how militaries think about logistics, field manufacturing, and the eternal balance between industrial power and battlefield needs. The techniques forged in those desperate years still echo today in military engineering. Disaster response, survival training, and even the maker movement of modern workshops. Take the British Sten gun, perhaps the most successful improvised firearm ever created. Its genius lay not in elegance, but in brutal simplicity. A steel tube for a receiver, plumbing pipe that could function as a barrel, basic springs, and a bolt cobbled from whatever metal was at hand. British engineers designed it so resistance groups with almost no infrastructure could create functioning submachine guns in basements, garages, even bombed-out buildings. In France, thousands of Stens appeared seemingly out of nowhere, built from car parts, plumbing scraps, and steel salvaged from bomb craters. It was a triumph of minimalism, an open-bolt blowback system that worked because it didn't rely on precision. It worked because it didn't need perfect timing or high-quality machine. It worked because the people who built it understood the value of good enough when the alternative was having nothing at all. Meanwhile, in Poland, resistance fighters followed the same philosophy. They welded kitchen knives onto rods to create bayonets. They packed gasoline and cloth into household bottles to form incendiaries. They crafted single-shot firearms from pipes, using furniture springs as firing mechanisms. But perhaps their most striking innovation came from the radiators that once heated Warsaw's apartments. Those Castillon tubes, arranged in parallel rows, were more than scrap. They were ready-made multi-barrel frames, waiting to be transformed. Fighters welded firing mechanisms to the back of radiator sections, packed improvised charges into each tube, and turned heating hardware into battlefield weapons capable of unleashing devastating bursts at close range. Across the world, similar ingenuity shaped survival. In the Pacific Theater, American and Australian soldiers isolated on remote islands built working mortars from abandoned Japanese water pipes. They welded base plates, scavenged elevation gears from ruined machinery, and crafted fuses using whatever they could pull from wreckage timers. From broken radios, powder from disassembled shells, metal scraps as casings. These weapons grew so effective that military manuals later included instructions for how to build them in emergencies. As the war dragged on, resistance movements learned to coax explosive power from whatever their occupiers overlooked. Fertilizer mixed with fuel oil, metal shavings packed into improvised containers, timing mechanisms scavenged from alarm clocks. All of these became the ingredients for locally produced demolition charges. They shaped blasts with welded steel containers, directed force with angled plates, and constructed detonation systems from simple circuits or mechanical triggers. These designs weren't just destructive, they pointed toward the principles that shaped modern demolition. controlled explosions, and industrial force direction. Behind German lines, Soviet partisans pushed ingenuity even further. They reinforced tractors to carry salvaged tank guns, disguised rocket launchers as farm machinery, and built mobile repair shops capable of crafting ammunition in remote forests. 2 German patrols. They looked like farmers plowing fields, but within minutes, they could transform into heavily armed units, attacking supply columns, then vanish back into the countryside. Before the enemy understood what happened, in the mountains of Italy, resistance groups turned railway steel into anti-vehicle weapons. They shaped rail sections into containers for massive charges, cut spikes into precision projectiles, and built remote trigger systems that could stop armored convoys in terrain where conventional anti-tank weapons were scarce. These innovations pushed the limits of what could be done with structural steel, welding equipment, and a deep understanding of mechanical force. In the frozen north, Norwegian saboteurs created demolition tools from skiing and climbing gear ski poles as explosive housings, bindings reconfigured into timing devices, waterproof charges designed to function in brutal, sub-zero environments. Their missions demanded stealth, precision, and reliability in the coldest conditions imaginable, and their tools set a new benchmark for what could be engineered in extreme climates. All of these stories remind us of one profound truth. In the harshest moments of history, human ingenuity becomes a force, as powerful as any army. The weapons built in those hidden workshops and icy forests weren't just tools of war. They were solutions created by people who refused to accept that superior resources guaranteed victory. They show us that intelligence, creativity, and determination often matter more than factories or supply lines, and those lessons are as relevant today as they were in the underground workshops of occupied Europe. Here at In the Beginning, we uncover the stories where desperation met innovation, where history's darkest moments sparked its brightest engineering breakthroughs. These improvised weapons of World War II offer more than historical fascination. They provide practical lessons in mechanics, chemistry, and problem-solving that still apply to modern engineers, makers, and innovators. If this deep dive inspires you to look at the world differently, to see potential in scrap metal, value in discarded machinery, possibility and limitation, then stay with us. Share this with fellow enthusiasts who understand that history isn't just a record of what happened. It's an instruction manual for how to think, adapt, and create. Because sometimes the greatest weapons aren't forged in factories. They're forged in necessity.